You're listening to OPIS Talks, where you'll be in on conversations with insiders in the energy, chemicals, and environmental commodities markets. Guests share insights into the latest trends and innovations, industry challenges, and much more. Let's dive into the conversations that explore where the energy economy is headed, right here on OPIS Talks.
Welcome everybody, good day. I am Benita Dreesen, Senior Analyst and Editor, European Renewable Energy. In this podcast episode, you will learn all about the current state of play of Europe's hydrogen market, about its challenges, and about what to expect in the year to come. But before we begin, let's have a little bit of background. Hydrogen and the development of a European hydrogen market got a lot of attention around the year 2020 when the European legislator, that is the European Commission, launched its hydrogen strategy report and defined also specific targets. Now today, nearly 4 years later, it is time for a reality check. And to do this, nobody is better placed than sector organization Hydrogen Europe. And with me to discuss today this topic is Greg Pawelec, Director of Regulatory Market Intelligence at Hydrogen Europe. So welcome, Greg. And to kick things off, could you please tell our listeners a little bit more about yourself and what you do at Hydrogen Europe?
Hi, Benita. First, thank you for having me. And as an introduction, I think maybe I would just start with a couple of words about Hydrogen Europe, as I think that's an important background. So we are an industry association, but maybe not a regular one, is that we are focused on not only accelerating the European hydrogen industry, as that's something you would expect from industry association, but we also want to do that as a way to achieve global carbon neutrality. And that's really important, is that those two objectives really go hand in hand, right? So we are not just a hydrogen association, we are a sustainable hydrogen association. That's also important then to understand my role there as a regulatory and market intelligence director. And that role is basically to be able to channel the expertise that our member companies have into position papers, into, to be able to create a single voice that then the European policymakers can hear and act upon. And also then to give some information back to our members in the form of market research, impact assessments of various regulatory files, clean hydrogen monitor reports giving a status of how the market is developing and so on.
Okay, thank you, Greg. So first of all, let's start with goals. European Commission in 2020 defined domestic green hydrogen production targets of 10 million metric tons by 2030. Another target was set. It was import targets of another 10 million tons by 2030. So my first question would be, are we on track to achieve these targets or have we been too ambitious?
The short answer is probably that we are not on track. To be honest, we should maybe acknowledge how ambitious those targets were, right? So considering that the total hydrogen demand in the entire EU, together with the UK and Norway, is around 8.5 million tons. So you can see that developing a market for 20 million tons by 2030 would not only require us to replace all of it with renewable hydrogen, but also to develop a new market from scratch for new applications of a size equal to 1.5 entire current market. So that's an enormous challenge, and you need to acknowledge that first. However, as challenging as that is, I think it's also fair to say that it's becoming increasingly unlikely that we'll be able to achieve it, which has also been recently highlighted by a report done by the European Court of Auditors, which basically called the European Commission to revise and maybe do what they called a reality check on those. However, to be also honest to the European Commission, when they published the Repower EU communication, which included those 10 plus 10 million tons of targets, it was also accompanied with a set of recommendations outlining what would be needed for us to be able to reach those. And that included, for example, that the target of use of renewable hydrogen industry should be set at 75%, that the target for using renewable hydrogen in the mobility sector should be set at 5% renewable hydrogen share in that sector. But then when it came to negotiating the final set of those targets with the co-legislators, with the European Parliament and the European Council, those targets were watered down a little bit, right? So that the industry target is not 75, it's only 42%. The mobility target is not 5, but only 1%. And then there are multiple multipliers and ways of even watering that further down. So it's actually only less than 0.5%. That's the target. What I want to say is that it's not that the targets were too ambitious. It's just the implementation is a little bit of a problem. So, and that's first when it comes to setting that framework and those targets actually, which account together for maybe 2 million tons only, right? So, which is a far shot from the 20 million ambition. But that implementation difficulty or problems also, that's on the Commission. In this case, is that the EU executive, they have taken far too long to legally define what a renewable hydrogen is, to set the rules about how to produce it. And those rules, once set, are overly complex and are really causing problems for companies wanting to develop those projects that are delaying the FIDs and so forth. So again, as I began my answer, the short answer is probably yes, the targets most likely won't be met by 2030 in the 20 million tons of hydrogen. It's unlikely that we'll see that much, but I don't think it's a problem of being too ambitious. It's the problem that maybe the implementation is lacking a little bit at the moment, unfortunately.
Okay, thank you, Greg. So let's talk a little bit about implementation, ambitious or not. So about production capacity, if you starting to produce something, we all need to develop first a strong infrastructure. This means electrolysis facility, transportation, and storage. Now, Europe, in its targets for electrolyzers, has said, we need to achieve by 2030 40 gigawatt by 2030 on the electrolyzer side. So again, is this realistic? Is technology efficient and up to speed to deliver on these targets, or is implementation a little bit behind?
So first, when it comes to this 40 gigawatt target, what maybe is often misunderstood is that this is the Commission has set the target in a maybe a little bit funny way, is that this 40 gigawatts refers to gigawatts of hydrogen produced. So if you translate that into electrolyzers rated capacity, it's actually closer to 60 gigawatts that would be needed to reach that. So that may be a bit of a clarification. But then when it comes to how realistic it is, I probably don't want to repeat myself, as most of the points I just made are as valid here for this 40-60 gigawatt target as for the 10 plus 10 million tons overall ambition. But what I think I want to say is that, because what you said is that is the technology efficient or up to speed enough to be able to do that? And I think the technology, and that's something we need to be clear about, the electrolyzer technology itself is not the bottleneck here, right? It is efficient enough and it is proven enough so that we can really rely on it. Obviously, there is always something to be improved upon. There are new technologies emerging which still need some R&D and so forth, like pressurized alkaline electrolyzers, for example. But still, the technology itself is not a problem. The problem is really to develop those large-scale projects, because where we lack experience is not how to operate electrolyzers, but how to develop projects in the gigawatt scale. Not only then run at full load all the time, but also need to follow the load of variable renewables. Maybe there is some flexibility adjustment on the industrial off-taker side that needs to be also maybe changed compared to the business as usual. So there are all of those bits and pieces that need to be really learned now, and that's what we need to also take advantage of the economies of scale and learning rules to drive the costs down, because the costs are also still relatively important. And then maybe what needs to be said is that in order to get to those large scales, we will indeed probably need a lot of taxpayers' money at the beginning, because it's difficult to imagine that the companies themselves will risk all that money just to learn and to drive the economies of scale and to drive the cost of electrolyzers down. That's something that probably at the very beginning we would need support from the taxpayers' money to achieve those objectives. But I think this is where the bottleneck and the difficulty lies, rather than with the electrolyzer technology itself.
Yeah, okay, good. We will come to the cost side and demand and project side in a second. But let's first talking about those targets. We have been talking about domestic production target. What about imports? Because European Commission also said we can't do it on our own. We need imports. So when you import, you need ports. You need hydrogen hubs, also probably ammonia hubs in the ports, because hydrogen probably will be transported over sea, at least through the conversion to ammonia. The Port of Rotterdam, wants to establish itself, is building an infrastructure to be the first import hub for clean fuels. So the question is, how far are we on track with the development to receive those imports, hydrogen imports?
Well, again, probably first we would need to see whether the target of 10 million tons of import by 2030 it's realistic, and then again we can maybe discuss a little bit about that, because if those demand targets have been watered down to be just amount to 2 million tons, then for 2 million tons it's probably that we can do a lot of it on our own, right? So it then becomes a little bit of a cost competition between who can produce it cheaper, rather than that we will necessarily need imports in the very short term, because we will not be able to produce 2 million tons. That's for sure not going to be that way, that 10 million tons is going to be necessarily already by 2030. It's a bit more long term, because by 2040 and going further into the future, we will certainly even need more than that, right? It's just a question about exactly where the timeline is when the 10 million tons will be needed. But then when it comes to the preparation about European ports, about being able to receive that, I think they are quite advanced. You mentioned Rotterdam, but there are also other ports in Belgium, Antwerp, in Netherlands, also in Germany, Wilhelmshaven, Hamburg. All of those ports are really quite advanced in their plans of being able to receive that hydrogen, whether it's ammonia, whether it's methanol or liquid organic hydrogen carriers or some other form. And indeed, they are quite advanced at it. It also helps a lot that this is not anything new, right? We are already using ammonia as a commodity. It's quite heavily traded globally, both ammonia and methanol. So the backbone in terms of terminals is already there. There is some expertise and knowledge about how to handle those as a cargo. So I think the ports are not the bottleneck here. They are well advanced in their planning, and they know how to do it and when to do it. They have extended networks of contacts with imports. They are signing MOUs all over the place. So they are quite advanced. The problem there is, as you know, is that it's wanting to deliver that hydrogen in whatever form in a port, but it's not going to be consumed in the port. It needs to be then delivered inland. And for that, you need also a connection to a pipeline network. You need to have ammonia tracking. You need to have all sorts of infrastructure to be able to deliver then that hydrogen to end users within the country. And you mentioned Rotterdam, and I think it's one of the examples, and the other countries that I mentioned, the ports that are as advanced as they are, in no small part because of the fact that the governments, national governments in those countries, have also taken leadership in this regards and are developing also the national hydrogen backbones, so that there is a visibility that the ports have and certainty that if they will bring that millions of tons of hydrogen in ammonia in 2030, they will have an opportunity to inject that hydrogen into a pipeline network that can be then delivered to end consumers. Because without that certainty, it's difficult to see also ports taking too much of an investment into a receiving infrastructure if they then don't have anything to do with that.
Okay, so if you say that those import targets are not very realistic or will need to be getting down a little bit, does it mean that investments in infrastructures at ports and pipelines should be slowed down as well?
No, not at all. And the opposite is true, actually, I would say, because the infrastructure, the pipeline infrastructure, that also goes with storage infrastructure, that's absolutely needed wherever that hydrogen will be coming from, right? Whether it will be produced within Europe or imported. What's sure is that if it's renewable hydrogen, it certainly won't be produced on site, right? Next to the steel plant or next to the ammonia plant. It will have to be produced where the renewables are. And that happens to be even within Europe, not the place where the heavy industry is, which will use that hydrogen. So we will need that infrastructure anyway. We will need that soon because it's not only needed to deliver hydrogen, it's also needed to be able to deal with those complex rules, which I mentioned previously, right? That we are putting the regulatory framework in place that requires the hourly temporal correlation to produce hydrogen, be hourly correlated with the renewable electricity production. And then if you have an off-taker in an industry sector with next to non-flexibility in terms of off-take, then you need infrastructure, you need storage, you need pipelines with line pack storage capacity to be able to deal with that, let's say, mismatch between the variability in supply and invariability in this case of demand. So I would say whatever the expectations is about, what the share of imports versus domestic production will be by 2030 and by 2040, infrastructure is certainly going to be needed, right? And I'm also quite sure that ports investing in infrastructure are also not doing anything wrong, because even if maybe not by 2030, long term, we will certainly need a lot of imports as well.
Yeah. Okay, so let's look at the demand side now. We know that hydrogen is not a universal solution for all sectors, mainly for the hard-to-abate sectors, as we say. Where do you see demand coming from in both short and longer term?
Well, I would maybe disagree that it's not universal. It is universal. That's one of its strong points, that you can use hydrogen as a fuel, as an energy carrier to produce electricity, produce synthetic fuel. So it is universal, but I guess I get your point, is that maybe that the fact that we can use it everywhere doesn't mean we should definitely also do it. And in some cases, it's maybe not the most energy efficient option, and then we can maybe reconsider. Fair point. With that in mind, indeed, heavy industry seems to be like the no-brainer, that it should be prioritized because they don't really have much alternative, right? For example, ammonia is probably the most extreme example here, is that you cannot produce ammonia without hydrogen molecule in it, right? So they really do not have any alternative than use low carbon hydrogen. But similar goes to steel. When we look at how much energy would they need, even if electricity would be an option in the future, just the sheer amount of electricity that would be needed on site to do the electrification of that sector would be just enormous. So that indeed, in the heavy to abate sectors, heavy industry, energy intensive industries, and steel, ammonia, refineries, cement, those are solutions where hydrogen should be prioritized. And then also heavy transport. We are seeing a lot of movement in e-fuels production for the aviation sector and for the maritime sector, where also, especially for the long-haul flights and intercontinental shipping, again, there is little alternative to e-fuels, and then hydrogen is obviously needed intermediary product to produce those e-fuels. So those would be my two main answers to what the short-term demand is going to coming from. However, I think it's important to also stress again the mismatch a little bit between where those priority sectors are and the rules that we have put in place in Europe. And that mismatch, I mean, is that with those temporal correlation rules that create a lot of headache for hydrogen producers who are really needed to produce hydrogen at a steady rate for heavy industry, which has little flexibility on the offtake side. Those rules are really creating a lot of headaches for the project developers, especially in those industries. So that's where the mismatch is, right? On one hand, we are saying that those heavy industry should be a priority, but on the other hand, we create rules that make life difficult, especially for those sectors, right? And that's something that maybe a little bit of a bottom at the moment. Yeah.
Okay, good. So what you basically say is those sectors will take off short term, and then there are the complex rules, and that's probably one of the reasons that the getting to the financial investment approval stage, the FID stage, is very difficult. Still very difficult. Analysts say only 4% reach the FID stage in 23. I think this year is nearly the same. after an FID approval, it still takes 3 or 5 years to build an infrastructure. So we are 24 now, so it takes us to 2027, 28. How to counter this problem? How to get more projects into this FID stage? To get things kicking off and rolling.
Yeah, well, so first, when it comes to those figures, yeah, they are right. The very little percentage of the projects are past this FID stage. We had a good last couple of weeks where we had almost a dozen projects getting that. So maybe the percentage is slightly higher at the moment, but it's still very low. That's true. And indeed, it's a problem that there are many reasons for it. So first is obviously the price of hydrogen is still at the moment too high for it to make economically sense for the off-takers to just buy it without either a support from the government or from the EU or whatever other source, or a clear willingness on the end user or the final customer to pay a green premium for whatever they are producing. We are seeing some good signs there. For example, in the steel sector, there are some automotive companies who are willing to pay a green premium for steel to be able to produce cars from it, because, at the end of the day, it adds just a couple of €100 to a car that costs, 30,000-40,000 euros. So it's not that much of an extra price, and it's worthwhile from marketing point of view. So there are sectors who are showing this willingness to pay a little bit more. You see that maybe in some logistic or shipping companies, maybe some beverage companies are willing to pay a little bit more for the transporting of their goods with zero emission vehicles. That's also happening, but it's still not yet sufficient on a whole sector level to really create a big enough drive for those FIDs. And maybe those are the two areas which we need really urgent action on. So first, either make a lot more money available for those first projects to be able to bridge the gap using that support money, or create market incentives to be able to translate the added costs of using green hydrogen to the end consumers. There's a lot to be done. We can, and there are also different sectors. That's a bit maybe a problem, is that different sectors have a different pain thresholds. Let's put it this way: if you would replace all the hydrogen in a refinery with green hydrogen, the cost of a final fuel at the pump will increase maybe by 2-3%, which you get a higher price spikes if important person in Middle East gets a flu, right? You get a higher price spike than that. So it would be completely manageable, but the problem is that you have to incentivize the whole sector to move in the same pace to change that, because otherwise it seems like not much, 2-3%, but on a company level it's hundreds, or maybe not hundreds, but tens of millions of euro of added costs. So no one will do that just out of their own free will, let's say, if the competitors are not doing it at the same time. And that's, I think, a key point. So either we need to address the supply side to make hydrogen cheaper, or at least to bridge the funding gap with using state aid at the moment before the economies of scale kick in and the costs get lower, or we address it on the demand side, creating a clear framework that either requires the off-takers to use certain percentage of hydrogen. That's what we see with those renewable targets, right, in the Renewable Energy Directive. So either we do that, we create a clear necessity of certain sectors to use a certain portion of renewable hydrogen all at the same pace, so that no one can get ahead of its competition, just not doing anything. Or we create also, and that maybe not or, it can be and or at the same time, create a framework on the market that also allows to translate the renewable content of the fuels that were used to produce certain products to be translated in a clear and transparent manner to also end consumers, so that when they buy products, they can choose if they want to pay a green premium or something. They can freely choose to buy something that's maybe a little bit more expensive, but they are in full knowledge and in a transparent way ensured that what they are really paying for is a legit renewable hydrogen use somewhere, and not just some kind of offsetting scheme that many people have a lot of doubts for, and probably justifiably so. So I would say those are the elements that are needed to move the FIDs a little bit forward.
Yeah, that's quite a lot. That's quite a lot of things to do. But let's zoom in first on the subsidy side to bridge this gap. So at the moment, what we have European-wise is the European Recovery and Resilience Facility Act and the Innovation Fund with will be 40 billion. And there is also the auctions of the hydrogen, Europe Hydrogen Bank. Now, the question is, are these funding programs altogether enough to kickstart the green hydrogen market in the short term, or is more needed?
I think it's clear that more is needed. I'm not saying it's not a lot of money, because it's already a lot of money that has been put forward, but it's grossly insufficient. I think that's also clear. When we look at the Innovation Fund calls, when we look at the Hydrogen Bank calls, it's clear that there is always, every year, a huge oversubscription. So you have 10, 20 times more projects applying that can be funded, right? So that happens every year, right? It's clear that there is a grossly insufficient amount of money. But it's not only the amount of money that's the problem, right? The problem is also the complexity of getting that. You have, again, Innovation Fund, Hydrogen Bank, have national funds, important projects of European common interest. You have Connect Europe facility for transport. You have Connect Europe facility for energy. You have the national funds. Then you have the modernization fund. And so the field is super complex. So you need a lot of expertise to be able to apply successfully to. You need to have a lot of expertise to even know where the money is, whether it's applicable for your project or not, and then you can spend a lot of time, effort to preparing your funding application, and at the end of the day, there is a 20 times oversubscription, so the chances of you actually getting the fund are not great, and that's obviously a problem. And you compare it to, for example, to the ERA in the US, where if you meet the minimum requirements, if your hydrogen is a certain emission intensity threshold, you get the money, and that's it, right? And that's a huge benefit of the ERA system compared to what we have in the EU. Even if you would again add up all those different funds together, which I mentioned, it's probably not that much lower amount of money that is available in the EU that the ERA makes available in the US. It's just that the complexity and the difficulty of getting it and the uncertainty of them being successful or the whole effort being wasted, which is the huge difference here. And I think that's a problem. But then again, I probably should go back to the point that I just mentioned. For the first projects, we certainly need that taxpayers' money to cover the gap. We need the support because the funding gap is still there. That's for sure. But I do think that if we design those targets of the end user targets in a really intelligent way, we can really reduce the amount of money quite significantly. I mentioned the refining sector, but also the maritime sector is similar. If you would ask from at a certain date, all the ship owners that carry cargo between China and Europe need to use only zero emission fuels. I mean, if you see how much that translates into extra cost of a pair of sneakers or an iPhone that is transported from China to Europe, it's just cents per item. So the end users wouldn't even notice that price spike. But from a point of view of a single ship owner, that's 20-30 million euro extra cost per each ship every year. And obviously, if they would just unilaterally decide to do that, they'd be out of business the next day. But if you design a policy framework in a really intelligent way that requires all of them to do the same effort at the same time, it can really a lot of be achieved without really requiring a lot of taxpayers' money to incentivize the first movers, and without creating a lot of pain for the end users for them to suddenly have a much more expensive products to pay. It can be achieved even without the funding, but in the framework that we are in at the moment, I think, yes, we would need probably more money. The way we are doing it at the moment, the amount of money we are putting on the table is not sufficient.
Yeah, probably. So as you mentioned, subsidies models can only go so far to bridge the gap. And there is an issue of viable business models because it's very expensive. If I look at the latest OPIS price reports, our assessment was that, for example, in July for the Netherlands, the price for green, so renewable-based hydrogen, was per kilogram in euro 6.39. This is 4.61 more expensive than if you would produce hydrogen based on fossil fuels, which is natural gas. And in Germany, the cost for green hydrogen is even 8.63. Now, if you compare this to the US, United States, and they are aiming with their Inflation Reduction Act to achieve $3.7 per kilogram hydrogen, green hydrogen that is, by 2030. So how can we achieve viable business models in Europe, and how can we be competitive towards the other regions as well?
So first, I think what you even highlight in your question is that there is some uncertainty when it comes to the pricing of hydrogen. I mean, you have your models. There are many others you can find on the market, which sometimes diverge quite heavily in terms of what they estimate the hydrogen cost to be. We do our own. Many consultancies do their own, and then you have someone saying that it's even now €4 per kilogram. Some others are saying that it's 10. We have recently published our report, which I think is closely aligned to what you are saying, so around €6-7 per, even 9 in Northwestern Europe. But it is a problem in itself, this cacophony of voices saying how much does hydrogen even cost, and then you have a hydrogen auction, which actually is a bit of a reality check and shows that the range to be between 5 and 12 even euros per kilogram in the EU. So it's a really complex question that would probably be answered differently if you are sitting in Spain, and would be answered differently if you are sitting in Poland, both from the point of view that the costs of producing renewable hydrogen are different in those countries, and also from the point of view that the off-taker structure is different. In Poland, you have a lot of ammonia industry, and the costs of producing hydrogen are really on the expensive side. That's, I think, safe to say. So that's one of the problems, is that there needs to be a bit more, I think, clarity and certainty about what the price even is, about for how much hydrogen can be bought. And there are some good, obviously, developments there. We have the H2 Bank, which I just mentioned, with this price discovery mechanism that they publish the results, and so that creates a bit of certainty about what the real prices are. We have the hydrogen index at the European Energy Exchange. There are many also products that can be obtained on the market, which create a bit of certainty. But then that's only hydrogen we are talking about. But when we talk about imports, then it's probably not good enough to say that the difference in hydrogen production costs in Europe between the US is X euros per kilogram, because there always is then the cost of how do you get that hydrogen from the US to Europe, whether it's in ammonia or methanol, and whether then it needs to be cracked or dehydrogenated back to hydrogen at the port of delivery, or can be used directly, because then all of that has a huge impact. If you can use ammonia directly without cracking it back to hydrogen, then indeed a lot of those import projects can make sense economically, because the price difference then gets translated directly to a cost competitive advantage. The cost difference, between producing it in the US or in Europe. But if you need to crack it back to hydrogen and deliver it to an end consumer, which is a couple of 100 kilometers inland, and to do it by pipeline, maybe do some storage in the meantime or in between, then this price difference between of a couple of euro per kilogram, 2-3 euros per kilogram of pure hydrogen production cost might not be enough to cover those added costs, right? It's an exceedingly difficult question to answer exactly what would those business models be, because again, those would in many cases depend on a country-specific conditions about what the renewable energy potential is, what the renewable energy production costs are, how is the decarbonization of grid even going in that particular country, right? I mentioned Poland. In Poland, if you would like to balance your variable renewables with grid electricity, if it's made from coal, the electricity in the grid, then it basically makes it impossible, and you have to rely on some storage solutions, so it makes it even more difficult, and then imports become more and more competitive versus domestic production in those countries. So there are a lot of those moving parts which will define the business model at the end.
No, I think it's safe to say, Greg, that developing a hydrogen market within Europe or internationally on a global level is complex, comes with a lot of issues, opportunities and challenges. You mentioned a lot of topics now today. Also the need for further regulatory development from the European Commission. But we covered, we talked about it today. And my last question would be to you is, how do you see the future, the immediate future? What are you most excited about in the year to come?
In the year to come, that's a specific, I think, timeline, because a bit long term, there is probably a bit of a different answer when it comes to a bit more further reaching future. But if it's just the next year, then I would say still I would expect the end of 2024 and maybe 2025 to be indeed a lot of FIDs happening. And that's something that I'm really excited to see, for a reason that, one, I do think that a lot of the very interesting projects are just on the brink of getting that past the FID stage, but also just from the pure maybe expectations of the fact that if we are going to be anywhere near the 2030 targets, those projects really need to start being approved this and next year. And we will have the regulatory framework in place. Okay, the RFMBO rules are not that great, not perfect, but we will certainly should have, at least by the end of this year, the low carbon delegated act, which will set the rules for low carbon hydrogen. The gas package is there. So there are still some bits and pieces of a regulatory framework missing here and there, but it's going to be largely in place by the end of the year. And then really no excuses anymore for the projects not starting. If the money is going to be also there, the off-takers' willingness to take the decarbonization seriously, I think we will see a lot of projects going past FID next year. And maybe on that note, also a bit of self-promotion, because we are, as every year, we are publishing a Clean Hydrogen Monitor, which is showing the state of the play of the hydrogen sector. And this year, in November, for the first time, we will also include an outlook in our monitor. So let's say our expectation about what we see will happen by 2030 and how much hydrogen could and will actually be produced in various member states. So if you're interested in a bit more comprehensive answer to that question about what I see happening in the next year or a couple of years, then that publication will probably answer all of them.
Okay, thank you very much, Greg. And there's also the event, the hydrogen in Brussels, the hydrogen event in Brussels with Shutter Lights, and you will give some presentation there as well. It was lovely to speak to you, Greg, again. I think you shed a light of lot of interesting topics. Thank you very much.
We hope you've enjoyed today's insider conversation on OPIS Talks. Join us next time for a deep dive into another industry insider's world. You can find more OPIS Talks episodes at opisnet.com/podcasts or wherever you listen to your favorite podcasts.